Nika Valeru, and this is my lab report for Lab 3 in Physics 2211. So the purpose of this lab is to model a star orbiting a black hole in part 1 and to model a ship moving around the star and the black hole in a figure-8 motion without crashing into a planet and a moon in part 2. The models and principles involved are Newton's second law, velocity update formula, position update formula, and the force due to gravity not close to Earth. Assumptions and initial conditions include force being a non-constant force, so in each iteration of the position update formula, the final velocity is calculated and used. The only influential objects are the ones that are listed. So the main idea, this is 3D motion in space with an unknown mass of surroundings in part 1 and an unknown initial velocity of system in part 2. The goal is to find the unknown values. So this is a preview of part 1, and the average mass of the black hole was found to be 1.88 times 10 to the 34th kilograms. In part 1, the system is the star and the surroundings are the black hole. Initial conditions, mass of the star is 2.0 times 10 to the 30th kilograms. Delta T is the number of seconds in 1 day. Initial time is 0 seconds. The origin is at the black hole, and the seed is my email. So this is what the code looks like. On the left, you can see the initial conditions and the formula for the mass of the black hole, which is based off of the force due to gravity formula. Initial and final momentum are the mass of the star times initial and final velocity. Delta V equals V final minus V initial. Delta P equals P final minus P initial. dP dt equals delta P over delta T. F net equals delta P over delta T. P hat equals the unit vector of the initial velocity. D mag P dt equals the magnitude of delta P over delta T. dP dt parallel equals P hat times D mag P dt. F net parallel equals dP dt parallel. dP dt perpendicular equals F net minus F net parallel. F net perpendicular equals dP dt perpendicular. So this is what part 1 looks like in a video. You can see the different arrows and their colors and what they correspond to. The star moved in an elliptical shape and the black hole was positioned slightly left of the center. So this is a preview for part 2. The initial velocity was found to be 25,000, 25,000, and 0 meters per second. The system is the spaceship. The surroundings are the black hole, the star, the planet orbiting the star, and the planet's moon. These are the initial conditions given, and the origin is at the planet's initial position. The spaceship starts by sitting on the moon. So this is what the code looks like. So for net force on the moon is the subject, and the planet and the ship are acting on the moon. Our planet to moon is the position of the moon minus the planet's position, and the F planet on the moon is the force due to gravity formula. The two masses are the planet's mass and the moon's mass, and R is our planet to moon. R hat is the unit vector of our planet to moon. For the force on the moon due to the ship, it's the same thing as before, except planet is replaced with ship. And then for net force on the spaceship is the same thing as before, except the spaceship is the subject and the ship and the moon. The moon and the planet are acting on the spaceship. And then for net force, the two components are added. For motion of moon and spaceship, the velocity and position are found by using the position and velocity update formulas. So this is what part 2 looks like. From this perspective, the ship did not move in a figure-8 motion, but it was influenced by all 3 other objects and moves without crashing into anything. So similarities and differences, there was a black hole and a star in both, and something was moving in a circular or elliptical orbit. Part 1 has 2 objects, while Part 5 has 5 objects. The ship, which is the system, does not move in an elliptical or circular orbit in Part 2. There are many more forces involved in Part 2 than in Part 1. So possible sources of error, since the mass I found is an average in Part 1, it could be more accurate if it was run for more time and or with more data points. The initial velocity of the ship might not be entirely accurate, since it is a guess in Part 2. So what does it mean? The net force is equal to dP over dt. Mathematically, the net force and the rate of change in momentum are the same. The same thing happens with their parallel and perpendicular components. However, the force is what influences the object and the momentum describes its motion. Since momentum is mass times velocity, the rate of change of momentum refers to the mass times the rate of change of velocity. It's the same for components, though the directions will be parallel and perpendicular to the object. The net force and its components describe the force acting on the object, causing it to move the way it does. For the what-if question, all 4 objects would need to be included in the system. However, some objects will dominate over others because they have more mass than the others. The black hole is the heaviest, then the star, then the planet, and finally the moon. The moon would have a much smaller effect than the black hole because it's not nearly as heavy. That's it for my Lab 3. Thank you for watching.